When it comes to examples of companies or people who have built core technology, whether it's chips, AI, robotics, and so on, we always turn to Silicon Valley. It is true, there are several companies who have risen from Silicon Valley to change the trajectory of technology. But I believe that there are enough examples of people from India who have made impact at a world stage. We have one such visionary in our midst today. He started his career at ECIL Hyderabad, where he was involved in national projects across space and defense. He was the first employee of Wipro's IT business and later became the global technology officer for Wipro and was instrumental in shaping Wipro's journey to become a global technology powerhouse. Not only that, he built a very strong R&D culture within Wipro, and he has been a role model for the rest of the industry to follow. Beyond that, he has also ventured into Next Wealth Entrepreneurs, which is the most recent venture he co-founded, which is a social cause providing gainful employment for graduates in small towns with a special focus on women. And across all the achievements that he has had for 5 decades of his experience in this industry, he remains as humble as he's ever been. So that is one of the most inspiring things you will know if you meet him. And I have interacted with him for a very long period of time, and that's why I say it. So thank you, and welcome to the show, Dr. Mitta. Welcome to Chai and Chips.
Thank you.
I could not think of a better person to start our Chai and Chips journey with. So thank you for doing it for us, and thank you for being here.
Thank you, Prakash.
So let me wind the clock back to where it all started, right? We are talking about 1970s or so. And this is the start of the technology journey for India. You built Wipro during the foundational era of R&D. Maybe we could start with, what was the business environment like at that point in time? What are the challenges? What are the opportunities you saw?
So let me start 1970s. See, the Indian computer industry has really started in 1971 when ECL was established by Atomic Energy Commission. The idea was to design, develop, manufacture computers required for projects of national importance, more like real-time computers and all those things. So in 1973, I joined them after completing my PhD in US and came back. So in a way, I can say that the Indian computer industry and my professional journey are fellow travelers. Okay. And at the time, the Indian economic scene was different than what we see today, because the initial governments of India were following the socialistic pattern of economic development. So there was a domination of public sector with a very small role for private sector. So everything you have to do industrially has to be approved by government. You need a license to start, you need a license to scale, you need a license to locate, you need a license to get foreign exchange, which was meager, and everything was determined by the government. So at that point in time, the government was looking at the computer scene. So in India, the requirement of computers at the time was the industry was nascent, and the computer requirements of data processing was met by IBM and ICL from US and UK with their obsolete machines and charging very heavily, and no technology inside the country. In 1977, the government mandated IBM to dilute their ownership of the Indian entity, which they refused and left. So thus, there was a big vacuum in the computer industry. So then what happened was the technology scene. As you know, 1971 IBM PC came into picture.
Yes.
It created a movement which IBM did not foresee.
True.
So at that time, all the computers, whether it's mainframe or mini computers, were proprietary in nature. So the development of all the subsystems, CPU, memory, controllers, peripherals, operating system applications were done by one company and offered. So they are proprietary. It also means you cannot move from one computer to another computer because there is no compatibility of them. So that's how the companies grew and made. IBM became bigger and bigger, so $70 billion. Second company, which was digital, was $7 billion. And all others were small, relatively. So when IBM PC came, the interesting feature is that they bought processor from Intel, operating system from Microsoft, peripherals from Sugar. So like that, they bought many subsystems from different vendors, integrated them, and sold as IBM PC. So this is called horizontal systems.
True. Yeah.
So IBM in a way has sown the seeds for movement from vertical computer, proprietary computer systems to horizontal systems kind of situation. So the advantage of horizontal system is they are inexpensive first, because we are getting best of breed subsystems from different vendors. You don't need very heavy capital to design all the systems. And from a customer point of view, they are not locked down to one particular customer or vendor or one particular computer and all those things. It gives flexibility for them. So this has created a new set of computer companies, which are relatively small all over the world. So this was the scene. So now enter Azim Premji. Azim Premji was studying in Stanford, and he has to return without finishing his degree because his father died. And he was asked to take over his business, which was Western India Vegetable Products Limited, making Vanaspati. But as an young man and a person with vision and mission, wanted to get into new technologies. So he was looking for a person who can spearhead this initiative for his company. So he found Ashok Narasimhan from Telco. So Ashok Narasimhan is a young, smart person who was working as a financial controller in Telco, IIM Calcutta MBA. So he met him in some occasion and told him, why don't you join Wipro? But name was changed to Wipro at that time. Okay. So he said, no, should I join? I'm already doing very well in a large company. Telco was the number one company. So why should I join? No, we are thinking of getting into new technologies. So Ashok asked a question, are you getting into computers? Because as a financial controller, he was using an IBM machine, and he was familiar with what computers are and what it can do for the organizations. So Premji, being smart, he told, yeah, we'll start if you join. So the deal is made. So Ashok joined Wipro and trying to set up things for getting into the new technology business. So that's the time Ashok was looking for somebody in technology area to spearhead this initiative of computer business or computer industry, computer business. So through his contacts, he found out about me when I was working in ECL Hyderabad. And his friend asked me, why don't you apply for Wipro? I said, why should I apply? So I'm already doing very well. I'm in public sector. I'm doing very well. So I don't have any interest to do it. So he told, whether you join or not, it's not my problem. But you fill up this application, give it to me. So I filled up the application given, and I was called for an interview by Ashok Narasimhan in Bangalore. So first thing which struck me was, here is a young man of 30 years old and general manager already and a smart guy and So it gave me enough reason to talk to him.
True.
So the discussion was, how do you start a computer company? What do you do? This one, that one, and all those things. So I never had an intention of joining Wipro. I said, okay, thank you very much. And as I was going, he asked me, when are you going back to Hyderabad? I said, today evening. So we want to join us for lunch. So I had a lunch with him. So then he asked the same questions again. So now I had to be, there no free lunch. So we have to answer those questions. And I told this what we do, 1, 2, 3, 4 kind of situation. So then over. I thought it's all over. Then I was called for an interview in Bombay, Bhaktawal, where Wipro was located. So I was not interested, but anyway, I thought I will go and see what is there to, what are they going to offer me. So then I was surprised to see so many people. So one of them is Premji, one of them is Brigadier Malhotra, who was head of LRD and retired. Sure. LRD was supposed to be the largest employer of electronic engineers at that time in Bangalore.
I didn't know that.
Yes. Wow. So there was an interview. I was not interested in the job, so things went off. And after a couple of other interviews, I was made an offer by Ashok Nasim to join Wipro. They said, hold on, first tell me what is the position. They said, R&D manager. I told you must be joking. So I am not a computer person. I did my PhD in control systems. I have not done any R&D. So I was more of a systems engineer or applications engineer, which is putting systems for the ECIL together. I may not be the person. But he said, no, we have done our research. You are the right person. So then I told that, okay, is it microprocessor based computer systems? He said, yes. Then I told him that I have 3 conditions if I have to join. First question is location. It should be in Hyderabad or north of Hyderabad.
And why was that? Why was north?
Because I visited these places. I never found to be at home in any of those big cities.
That included Bangalore?
No, Bangalore. I said south of Hyderabad. Okay. Not Hyderabad.
Okay.
South of Hyderabad. It could be Bangalore, Chennai, Trivandrum. Could be any place.
Understand. Okay.
So he said, location we are not decided. We'll keep this in mind. The second question is, I need to have freedom to choose my team. He said, okay. 3 is, who is going to be the CEO of this new company. So we are not decided. Unless you are there, I won't come. He smiled and said, okay. So the offer was made. And I said, let me think about for 15 days and come back. So meanwhile, what was happening in ECL, I was very happy doing projects for defense, space, message switching systems for Air Force, satellite tracking systems for Department of Space, all those such things. But I was following microprocessor development from my PhD days. Okay. Intel introduced first 4004, 8008, 88, 8080, PC and all those things. Right. So Intel announced a 16-bit microprocessor, 8086. So then I studied them and found to be more powerful than the so-called mini computers which Wipro was developing using that generation technology. Okay. So I thought that's the right one to do. So I sent, I submitted a paper to ECL management saying that we should use microprocessor technology for our future mission. So every one of them told that, no, we are a mini computer company. Microprocessor are toys. So I thought this is time for me to leave. Okay. And meanwhile, I also had some experience of using 8080 processor in some of the defense applications in ECL itself. So I was hands-on.
Can I ask you a question on that? What made you think the microprocessors that you were testing and talking about would be more important a shift than pursuing mini computers?
No. It made a huge difference. See, this is the cornerstone of horizontal systems from a vertically integrated.
True.
And the small chip with so many thousands of transistors giving the power of a CPU, where we used to make huge, rack of electronics.
Okay.
So then memory, then the controllers and all that. So this is not just a microprocessor alone, it's microprocessor technology.
Right.
So the ability to put in so many transistors in a small chip to do different functions. It goes from CPU to controllers to other things. See, what is a controller? Controller is nothing but a microprocessor, specific microprocessor for controlling a device. Okay. So this technology I could foresee. Number one, growing. Number two, it is giving an opportunity for a new set of companies, especially in India when there is no installed base of computers and there is no investment to protect.
It's a net new technology. And which year are you talking about here?
I'm talking about 1973.
1973. Okay.
Sorry, 1980.
1980. Okay.
Yeah, 73 I joined. 80 is this one.
Yeah.
So the reason I thought I should join Wipro, Wipro is one number because microprocessor technology. Second, they are starting with R&D rather than marketing or factory or other things. Okay. And that thing is, I told Ashok, I'm thinking of doing something on my own later, 2-3 years later. So I don't want to join. He told Sridhar, look, Wipro, you are starting from scratch. We are going to do things. So after 2-3 years, it may succeed, it may fail. If it succeeds, you know how to do things. If it fails, you know how not to do things.
That's a good logic.
Okay. So it's a good amount of discussions and logic to join Wipro.
Yeah. And when you joined them, right, you mentioned 3 years or so you wanted to start something on your own, but it was still risky to join Wipro at that point in time. What made you shift from ECIL to them?
Yeah, it was risky, but the question here is there is a pull and a push. Push came because ECIL did not look into microprocessor technology.
Right.
Pull because of Wipro using microprocessor technology. Okay, that's the thing. And secondly, Wipro was looking at the data processing segment, whereas ECIL was looking at real-time segment.
So, Dr. Mitta, for audience sake, in simple terms, how do you describe the segments?
So, I was telling about Baba Atomic Research Center, BRC. It was a Atomic Energy Commission, because of which the advanced countries put restrictions on what they can import. So, in fact, even simple things like oscilloscopes are not allowed for them to be imported. With the result that BRC has started investing in developing these such things, both products and tools which are required for the atomic energy. Obviously, computers were required. So, first they developed analog computers. Then they developed a digital computer using second generation technology, which is transistors. It's a 12-bit. So you may ask why 12-bit?
Yes.
12-bit is because at that time the sensors were having a accuracy of plus minus 1%.
Okay.
So if you convert into bits, it becomes 12 bits. Oh. So even if you have more, it is not going to help. So because the signals are coming from in real time, from other devices. Okay. So it was a 12-bit was done. Okay. So having developed it to productionize and to do for other projects, which is outside BRC. So they wanted a separate entity, legal entity. So they created ECIL, Electronics Corporation of India Limited, as a public sector under Department of Atomic Energy in Hyderabad. So that's how it has come. So initial customers were obviously BRC, Department of Space, and such customers and such projects.
Okay. Okay.
Whereas data processing is payroll, inventory control, and all this kind of thing, which
the
is
usual
required by
business.
which is required by all the businesses.
Businesses. Okay. So, segue I wanted to make is you're talking about microprocessors and the subsystems, vertical to horizontal transition that was happening. You had to make a series of bets on which microprocessors to choose, which subsystems to choose. What principles did you employ to arrive at those decisions?
Okay. Actually, I would say it's a common sense, but many people didn't do it. So first, me, Ashok Narasimhan, Premji sat together and said, what are we going to do? What is this company going to do? Build computers, microprocessor technology, fine. But what segment? Is it real time? Is it academic and research? Or is it data processing? So the answer is quite obvious, data processing, because that's the biggest market, nascent market, and unmet needs are there.
In India.
In India. We are talking only India.
Correct.
Okay. The second thing is what processor you are going to use. So it could be 8-bit, it could be 16-bit, because 16-bit has just been announced, as you know. So many people advised us, saying that because you are a new computer company, you start with 8 bits, get some experience, then go to 16-bit. But I did not believe that, because in technology, being ahead of time is always an advantage, because we can kind of a leapfrog.
Right.
Kind of, it's an advantage rather than disadvantage. So we said it's 16-bit. So the next question is, do you want to use a standard microprocessor or buy bit slice? In bit slice, you buy 4-bit ALUs, arithmetic logic units, stack them up into 8-bit, 16-bit, 32-bit, whatever you want. And you have to create an architecture instruction set. Just quite involved and difficult. So many people tried that and failed. And also in India, there are not many people who can do this one. At least in Wipro, we didn't have. So we said we'll go for standard microprocessor. Then the question is whether it's Intel or Motorola. So before choosing the microprocessor, so we went, me and Ashok Narasimhan, went all around US, went to these companies, Intel, Motorola, Digital Research, IBM, HP, Digital, all these companies, to see what is happening. And we found that Intel gave the best option, because they said at the time, we have 8080, we have 8086, we are going to have 32-bit machine, which is compatible to the 16-bit machine, so that the same software will run on the new processor also, and then we'll go further. Second, they said we have a development system. We have development tools. So if you're a computer company, you need development systems, development tools, and all those things to design it. So they had a thing. Also, they had boards and subsystems, which initially you can buy and start the development and then slowly change them one by one. So that flexibility was there. So all these things pointed to going with Intel, even though microprocessors from Motorola was supposed to be technologically better. So Intel advantage is compatibility. Disadvantage is they have to be compatible to the previous generations. So it was a trade-off.
So for a company starting off, it made more sense to pursue Intel.
Okay. So having chosen the Intel processor, next question is in terms of whether you need a standard bus. Bus is a mechanism in which different subsystems are stacked in a modular way, so that you can remove one subsystem and put another subsystem without changing the other ones. It's a huge advantage. In fact, in ECIL, I suffered from not having a standard bus, because every time you do something, you can. So one is to design a bus, other is to look for a standard bus. there are no standards at that time, but Intel has come up with a multi-bus, which is an internal standard by Intel, but they published all the definitions so that people can use it. So we chose Intel multi-bus, which later became IEEE standard. Okay. So after that, the issue is what kind of peripherals you want to use. So that's the time when Al-Shugat defined and introduced a new set of computers called Winchester disk drives. They are hermetically sealed, requiring very environmental conditions. Okay, whereas normal disk drives at that time used to be like a washing machine having 7 megabytes of capacity, removable disk drives. So you need dust-free temperature. Everything has to be controlled.
And we have come such a long way on storage.
Okay. Whereas this one is very small, relatively small, 14.5 megabytes. Yeah. And the environmental conditions are not severe. Okay. So we chose that. So then what happened was all the subsystems, hardware was straightforward, and we did that. Actually, when you look back, there are several companies which came in India at that time. One company was started by Stanford graduates, very smart, very good guys. They didn't follow this simple logic. So they defined their own processor. Mm-hmm. They defined their own bus. We needed a lot of money, which they didn't have. And they were behind, kind of situation. And not only it helped us to put in a system very fast, within a year, it helped us next 10 years as Intel was going with the new processors. So we are able to quickly adapt.
And which company are you talking about?
PSI.
PSI, okay. And during that time, I'm sure you interacted with the industry visionaries on the Valley side. Can you recall any of the anecdotes which could be interesting for our audience?
Yeah, it's interesting because we went and visited so many companies, US, UK, and all those things. So they were still in proprietary systems. They were so confident they know everything and they are the right one. Just give you one example. So Siemens was number one, and Nixdorf was number two. Mm-hmm. So me and Ashok Sudha went and visited their company in Germany. Everything was fantastic, so big kind of situation. And they looked at, they showed us where they design computers, where they design PCBs, where they design housing. So all those things. So we have these tools worth few $1 million. This is the thing. This is the connector. This is the everything was so perfect. So we had a final meeting, and I asked the question saying that, "What is your processor? 16-bit processor. How many MIPS it is? So many MIPS.
And MIPS is
million instructions per second. Okay. So then I was shocked. Their MIPS is less than 8086 MIPS. Okay. That means 8086 processor is better than that. Okay. Then I said, what bus you use? No, our own bus. Okay, fine. And each PCB was made with a shield, golden contacts and all those things. It's a piece of art.
And PCB is printed circuit board.
Printed circuit boards, okay. So, all those things. Great. Then I ask you a question. What is your operating system? Or proprietary operating system? Okay. Then why should somebody buy your computer if I have this higher performance with a lower cost based on microprocessor? No, Dr. Mitta, there's a secret. I said, what is the secret? We have Comet. I said, what is this Comet? This is a set of software programs which you have written. Covers all possible things which a business needs accounts payable, accounts receivable, this one, all those things. And we spent so many years, so much of money building it, so much of time. Nobody can replicate this. So that's our secret. Then I asked you a question. So what language did you develop? That basic. So I was, laughing to myself. And then I asked him what database you are using. No, a proprietary database. So the net is, everything is proprietary. It's very expensive, fantastic company, fantastic computer, but price is 10 times
very
more.
high. Yeah.
So after coming out, I told this company will not survive more than 4 years. A startup company from India going to Germany and looking at the obvious, and they in that business they could not
Can't
see it.
Yeah.
So it went bankrupt.
Yeah. Then it got acquired by
Siemens.
Yeah.
So
Such an interesting
that's the
story.
kind of thing we used to. Similarly, another company in UK, similar situation. So there are many people who don't see, successful companies don't see what is coming next.
Around the corner.
Around
Yeah.
the corner next. Same story repeats again and again and again.
It is known to everyone, but it's so hard to beat what they call entropy. So you talked about hardware elements. Can you elaborate more on how you chose the software elements?
See, the choice of hardware was very straightforward. Okay, what is a processor, bus, and all those things. When it came to the operating system, there are two options. One is you develop everything from scratch, it takes 3-4 years, and it's very complex. Second option is to buy an operating system from a vendor. But at that time, there were only 2 operating systems available. So one was from Microsoft, MS-DOS or PC-DOS. The second was CPM from Digital Research. So these were developed for 8-bit personal computer machines. But they are not suitable or does not use all the facilities of 16-bit 8086. So there are no things. Secondly, the usage in India is different, data processing versus personal computer. So we were looking for licensing any operating system if it exists. And we started looking and went around the United States. We were lucky to find a company called Sentinel Computers. It was a startup company. The background is Cincinnati, they have Cincinnati Millecron, which is the world's largest numerical control company. So they were using computers, Motorola computers, for their own these things. So one day they decided we should get into commercial data processing. So they formed a separate business unit, hired people, and started making and selling those machines. Obviously, they don't know how to sell commercial machines, being a NC company. So the board decided to close it. So the people who are working didn't have any other option to get out, and they started this company called Sentinel Computers. At that time, there were no VCs and all those things, especially in Ohio.
Yeah.
So then they wanted to build a computer which are application specific. So they quickly zeroed on Intel, where they bought all the hardware. CPU, memory, disk controller, communication controller, all those things, including power supply and rack. So put together a computer in no time. It so happened that there was a company called Tomini, a few meters away from Sentinel.
Wow.
And that company was started by a guy by name Tomini. Tomini used to work for Syncom. Syncom is Cincinnati Computers. They produced one of the world's top 2 databases. One was IBM, other is Syncom Total. And it was very well received by the industry. So this Tomini guy told, we are doing for mainframes, what do you want to do for smaller computers like IBM Series 1? The board vetoed the proposal, saying that we are a mainframe company. Why should we worry about the small companies? Small computers. So he left and started this company for operating system combined with database running on a smaller mini type computers, IBM Series 1 type. So it suited them. So Sentinel people met Domini and negotiated, and they licensed it. The problem is the original is written for Series 1. This is for Intel 8086. Okay. So they have to kind of transfer that to the Intel processor. So they bought an Intel development system and all those things using PL1 language. So they quickly made an operating system.
They had to recompile it?
Rewrite, recompile.
Yeah.
Kind of situation.
Yeah.
It is called porting. So they ported from IBM Series 1 to Intel 8086 processor. Intel 8086. And the greatest thing is, number one, it is multi-user, multitasking, and a database built in, and a lot of tools to develop software online for the applications. So they all comes in a small package, which needs least memory kind of situation. So they started using that one. And now they found another vendor who will develop applications such as accounts payable, receivable, and all those things. It will run on this. So Sentinel was targeting small enterprises, this combination. So we said we are interested in licensing the operating system. So will you give it to us? He said, no, why should we give it to you? You guys will copy and run away. I said, if I'm copying and run away, we will come to you. In fact, the other way, if you license it to us, we'll protect you if anybody copies in India. Right. So we are an ethical company. Right. So we want to use your operating system, and then build on that operating system which we will use for commercial data processing. Okay. So we said, this is the opportunity for you. So a lot of discussion, they agreed. And to give the source code and the technology, if any. So then we agreed, we signed the contract. So we had to pay money for them in foreign exchange. As I told you, the foreign exchange is scarce in India. Difficult. And we went to the government and said, we want to pay this company this much of money. Please allow us. So we are paying actually, but only foreign exchange is the permission from the government. They said, why are you coming and asking? Nobody has asked this before. Everybody is copying, you copy it. I said, no. If you copy, the industry will not come up. So the software industry builds on not copying. Right. So if you want to build an industry, you should pay for it. The second point was that there is nothing defined in the import-export trade policy of India what is software.
Wow.
Okay. So how can you pay for
something that is not
something defined? Is not defined. So there was some good people in the department. They came up with a solution calling it as a design and drawings. Okay. So we are allowed to import design and drawings of an operating system. Okay. For so many $1,000. It is the first time in India government giving permission to import software legally by paying money.
Incredible story.
Okay. So then when we bought this one, we had a problem. So the software will come in at that time 8-inch discs. Right. Some 100 discs. But when you brought those things, we declared at the customs. The customs officer looked at it. What is this? I don't know. And so much of value. No. I will confiscate it. So he confiscated and took a big nail and put them through it, Just like in government office, they do it. This, now you go and appeal. I don't want to take any decision. But fortunately, Lee Cole, who is the vice president of international for Sentinel, was coming. He bought another set of disks with him so that we can start working on that. And meanwhile, to justify that we paid properly, we have to make a hot copy of the operating system, because it's design and drawings, and it cannot be in disguise which they don't know what it is. So then I put bundle it. So this is what we imported, kind of situation. So that's the level of technology, government, and all those things which has to be done. And when you are doing for first time, you have to go through all these things. So that's how we got the operating system. The first computer was called Wipro Series 86.
And when did you launch it?
We launched it in 1981, February, in the Computer Society of India annual convention. See, the CSI annual convention originally started as a scientific academic get-together. And slowly it has reached a stage where companies which are coming announce their products or these things in that conference. So in 1980, I joined in May. So by December, we have one prototype using bought-out subsystems from Intel and operating system from them. Only one system, only one terminal. And we have to take a decision to whether announce it in February 81 or wait until next year.
Right. By which time you lose close to a year.
Close to a year. Yeah. More than a year.
Yeah.
So if we have to announce the product, we have to be ready in the next 2 months. We don't have drawings. We don't have spares. We don't have anything. And what do? So we decided to announce anyway. So we quickly put together the system. We didn't have a second terminal. And how can you announce a computer multi-terminal with one terminal? So we had to go around the country and find out one company in Chennai had a similar terminals. So we begged them, borrowed those 2 terminals for the announcement in Delhi. And we had to change the firmware of that terminals. We didn't have a prompt programmer. So all kinds of things. Challenges. Finally, when I had the prototype the day before the conference, the machine didn't work. So we didn't have diagrams. Power supply didn't work. We didn't have the diagrams. So our hardware manager was a power supply expert. So he did things and said, let me go to temple and come. It's a last resort. He went to Malai Mandir in Delhi, prayed and came. And he started working. And next day we took it and put it there.
Okay.
And the computer was so small compared to rooms worth of full of these things. It was a desktop, one like a dryers. The whole computer was in the dryer. So it's like, if you come and see, it looks like a table, office table.
Right.
So when we demonstrated this in the thing, people said, where is your computer? It's there. No, I don't see computer. I see only table.
Right.
No, your guys are cheating. So next day what we did is we opened the computer, put backside to the front.
Okay.
So that people can learn something. Really there's something. And we are able to run programs.
Right.
And we challenge the people. You come with your programs, we'll run it.
Okay.
And Ashok Narasimhan made the formal announcement in CSI.
Okay.
That was a breath of fresh air. And it was so nice. The computer was so good and presentation was so good.
Wonderful.
So Wipro, from an unknown entity, became a known entity in one day because of this thing.
And how many years of work did it take you to get to that point?
It's less than a year.
Okay.
I told you I joined in May.
Right.
I went to US first time in August. We came back. Then two people went to Sentinel to get all the technology transfer, all those things.
So very quick turnaround to create and stand up a new system.
That's because of the decisions we made in the beginning.
Yeah. The choices you made on different subsystems, components.
Correct.
Yeah. What a fascinating story.
That's the beginning of microprocessor-based mini computer system kind of situation. Now, I forgot to tell you one more thing. Why location-wise? See, the government of India specifies where you should set up your company. And every year they announce industrially backward areas where you are allowed to set up the company, not anywhere you like, if you have to get a license. So at that time, they specified 3 places. One is Aurangabad in Maharashtra, in fact, which is close to Wipro Vanaspati factory.
Okay.
Second was Patancheru near Hyderabad, where there are nothing but green fields.
Right.
Third one was Mysore.
Okay.
Mysore is a developed, decent city. So I said, north of Hyderabad is not allowed. Hyderabad, Patancheru is not good. Obviously, choice is Mysore. So Wipro came to Mysore first, as per the government conditions. Having come to Mysore for factory, we came to Bangalore for R&D and marketing and all those things.
Right.
So many people think that Wipro came to Bangalore because of good weather, Indian Institute of Science, all kinds of public sector, talent and all this. No. We came because of government in Mysore factory, and because of which we came to Bangalore.
That's a good clarification for our audience on how Bangalore came to become the Silicon Valley of India the way it is today. Yeah, that was the start of it. So you talked about the entire journey of starting out as a hardware business, and I have had the good fortune of selling some of the systems built by you and your team when I started my career in Wipro. And I must say it was a very proud moment on hardware built in India at that point in time, which we used to sell. Wipro Super Genius machines was one of the systems I remember, which came later. Yes. So fast forward a few years. So the first 20 years or so, the focus was to build design capabilities within Wipro R&D. And the next years onwards, it would be more oriented towards building global scale capabilities and making Wipro the name what it is today. So how did you go about it? What were your learnings through that journey?
The government was thinking of liberalizing the entry of foreign companies. See, so far, the Indian market was a closed market. So the competition was between Indian companies. So as long as you are better than another Indian company, you are all right. Correct. So we never faced any global competition. So in 1990, government said we are going to allow foreign companies to come in with certain conditions, like 60% owned by foreign company, 40% owned by this one. So it sent shockwaves to Indian companies because, number one, they are large companies, global companies. They have technology, they have money, they have marketing, they have all the abilities. Only thing they may lack is how do you market in India and support in India kind of situation. So that is a general thing. So I asked a question as a head of R&D, what is the impact of this company, this decision if government takes, as and when it takes, on R&D. So it dawned on us, so if door is open for somebody to come inside, it's also open for you to get out.
True.
Okay, but on a global scale, we are a tiny company. So we started looking in why the companies will be interested in Wipro kind of situation. What is that unique thing which we can offer. So that's when the thing hit us, because Unix was becoming a mainline operating system, moving from engineering workstations to commercial systems. There's a lot of demand for Unix talent. And we were lucky to have AT&T Unix source, and then having implemented on 386 and many other machines, we had a talent which is well versed with Unix. So we started offering Unix-based services to global companies, which there was a global shortage of Unix talent. But we asked ourselves, why should that US company give it to us? Because we didn't want to send people from here to US and do the work, like the body shopping. But we want to do work from India. So there are three impediments. First thing is, how do they trust Indian company?
In Indian company.
Okay. The second one is, what is your infrastructure? Third one is, what is the quality and timeliness you are going to give? So these are the three questions anybody will ask. So we started thinking on that. So first, in terms of trusting, so we have to project our credentials already, which has come in terms of we are a trustworthy company and those things. Second is, we have to have quality standards, which said that not only meets quality, but I am going to give in time. So we looked around and said, are there any international quality standards which we can follow, which the customer looks at it and we look at it, agree on it. There are no standards, software standards at that time. Then we thought, why don't we use ISO 9000, which is actually for factory. In fact, Wipro factory got
ISO
9000 accreditation.
Right.
It was meant for factory. So we took that factory
Certification.
Factory standard. How to implement for software. Probably we are the first company in the world to use ISO 9000 for software. Okay. So when the potential customers come here and we show that we have this quality system, we say what we do what we say. These are all the tools we have. These are all the information about how we are developing, and we can share this with you online so that you don't have to get a shock saying that I'm not doing it, I'm not quality and all those things. It was a easy sell because none of the companies, they didn't have any standards. Right. I mean, they may have internal things, but they don't have international standards. Right. And then Carnegie Mellon University came up with CMM level 1, 2, 3, 4, 5. So ISO 9000 software is equivalent to level 3 of CMM. So we got ourselves upgraded for level 4, and we had training. All these people from US will come for accreditation. And we were kind of first time we got the approval for level 5 in India. At that time, there were only 3 companies in the world which got this. One is IBM, Motorola, and some other company. And they got for specific project or specific division. Whereas in our case, we got level 5 for the whole company kind of situation. So that was another unique thing. So in terms of infrastructure, we had a problem to guarantee the thing. So the communication was a problem, internet. It was controlled by Department of Telecommunications. So at that time, we used to have a head of Department of Electronics, Mr. Vittal, who saw this problem and given a very fantastic solution. He said, okay, DOT doesn't want to lose control because government control is required for communication. He started another government agency called STPI, where he kept an antenna to receive directly satellite communication, still owned by government, and from that satellite you can get connections kind of situation. So he circumvented all the things which was required. So then in terms of power and all those things, we had generators in the basement, we have this one storing of diesel required for next 30 days. All kinds of things we did. So most important thing was the communication. So when we did all the things, our idea is to set up a center in India which mimics the center of the customer.
Okay.
So same machines, same tools, same intercom system, everything. So we called it India Development Center, which later was called ODC, and now we are calling them as GCCs.
Got you.
The first time we did before anybody else did that kind of situation. So India Development Centers. So when these things were happening, there's another requirement which has come from Indian market. So when the defense needed computers, they needed rugged computers. Rugged computers means they have to withstand high temperatures, low temperatures, shock, vibration, and electromagnetic radiations and all those things, which takes a lot of time. And then they have to develop application software. So what we suggested is we'll give a commercial version of the machine where you can develop the software. In parallel, we'll do the computer's ruggedization. So we did that. So that was used for all the defense missile projects. So Dr. Kalam was in charge of DLRL. So he came up with this initiative called Integrated Guided Missile Systems. So several missiles, including Akash, which came into this one recently, we given test systems, rugged test systems for that.
Okay.
Similarly, NAL was working on computational fluid dynamics. So they needed huge computing resource, which was difficult to get it. So there was a mission, CRE, in Delhi, where they can't go and use it. Even if they get a time, they get for 10 minutes, 15 minutes, like that. And NAL, which is the spearheading this work, they had very obsolete CDC machine, which takes hours and hours to do one iteration of this thing. So one day, the scientist from NAL walked into my room and said that I need a parallel computer. I said, we don't do parallel computers. We do commercial computers. No. You take your CPU, put second CPU, third CPU, fourth CPU. So we don't have software that. No, I will write the software.
Interesting.
So you give me a small kernel, I do a thing. This guy, what he had done is, he has taken the computational fluid dynamic problem and cut it into 4 pieces. Each piece running on one CPU simultaneously and giving the answer. This domain decomposition technique, which they use. So I was little kind of skeptical whether it will work and what he says. Because this guy, big beard and all those things, he murmurs. We don't even understand what he says. Typical scientist, But I could establish a common wavelength.
Right.
So I told his name is Dr. Sinha. Sinha, we will do one thing. I will not sell the computer. I'll put up a computer in my lab. You come and do all the things and prove it works. Then I will sell you. So he liked it. So he came, did that one. So 1 processor performance X, 4 processor 4X.
Okay.
Fantastic.
So true scalability.
True scalability for that particular set of problems.
Right.
And the performance 4X is better than his mainframe. He said that if I buy this machine, I have a machine for 24/7 for myself. Why should I go on
10 minutes
big time on these things?
Yeah.
So that's how we sold first machine. It was called Flow Solver. Okay, to NAL. So he was so happy and so greedy. I want 16 processors. 16 processors. More than 16 don't work. Then we had, this was first 8086. Then we have put 386, 16 processors, Mark II. Then we had 860, put that one. So he was constantly getting highest performance at lowest cost and beating even the performance of Cray in his own lab. So like that we did parallel computers for several people. So all these projects of national importance, which people don't get it from outside India or even not allowed to get it from India, or it takes time to develop, we're able to do it very silently without conversation, because of which Wipro R&D received Award of Excellence for Electronics for 5 continuous years. Okay. So this was the contribution to the Indian side. Then on the other side, we told you ability to do software development from India for US companies. Yeah. Just think. So when initially it worked out, the India development concept, we found that it's a big opportunity. Because customer is happy because his cost won't that. Wipro is happy because it's making 40% net profit.
Right.
Government was happy we are getting foreign exchange. Okay. Employees were happy they're working on the latest and current technology. So we thought it's a good opportunity. So we should form a separate business unit. R&D, which was a cost center in Wipro, became a profit center and called Global R&D.
Global R&D.
Okay. While doing this work, 2 other interesting things happened. One was when I'm designing hardware for US companies. So initially it is integrated circuits, VLSI, LSIs. So then we have gate arrays. Then we need to make specific VLS.
For our audience, if you can explain VLSI in simple terms.
Very large integrated circuits. Okay. So which has a lot of transistors and a lot of functionality in a single chip. Then we reached a stage where we had to do more performance in the chips. We had FPGAs, field programmable gate arrays. It is like a computer prefabricated and give the performance by programming the layer. So hardware, one layer is fixed, one layer is programmable. So then it became obvious saying that hardware designers has to be VLSI designers if they have to continue to work with companies. Even though there was no pressure on Indian side, there was a thing. But to get a VLSI experience, it is a tough choice. We need an engineering workstation which costs ₹1 crore. We need a VLSI tool which costs ₹1 crore. Okay. And then we need people to be trained, it costs ₹1 crore. So the total capital budget of Wipro during that year was 4 crores. I wanted 3 crores only for this project.
And which year was that?
It's about 1990, early 90s. Okay. So I didn't even go and ask for it because I know the answer. So we had to come with a smart way to do it. So then I found a company which is not spun out of people working in VLSI technology in US came out to India to develop chips. They have the idea, they have the experience, but they don't have money. They don't have computer, they don't have a workstation, they don't have anything. So I went to them and told that, look, I will get you some workstation to design. If you get the VLSI tools, legal version, on my machine, you can use one shift, I can use another shift. Okay. So they have fantastic conversation. So then I went to our finance CFO, told him, said, I need a 1 crore computer, Sun computer. How do you make it happen? And explained to him why I want it. He told that no problem. See, we are distributors for Sun Microsystems. Mm-hmm. If I get one thing, it adds to the overall sales of Wipro. And we get a discount, obviously. So he collected all the money, unused money, and allowed me to buy a Sun workstation. So I have workstation, I have VLSI tools. Now I need training. We found another manager in VLSI Technology US. They used to design customer-specific chips, ASICs. Okay, application-specific integrated circuit. So he was actually designing the subsystems for Apple computers. Okay, and he needs system designers, not chip designers.
Right.
See, these two are two different things. One is a system knowledge, other is a chip knowledge.
Chip knowledge, yeah.
So very few people were available at that time who had both these things.
Yeah.
So I told this gentleman saying that I have system designers who design high performance, high speed systems. 386, Pentium and all those things. Whereas we don't know how to design chips, tools. So we'll send two of our engineers. You train them for 3 months or 6 months and use them for 6 months. Don't have to pay anything. I don't pay anything, you don't pay me anything, because getting foreign exchange is a problem. So these two guys went there, in month and a half they learned the tool. They started designing the chips, which were first time success.
Okay.
So they liked it so much, saying that, okay, now that we are designing, you come back, you go to another team. So I built a team of VLSI engineers. Over time. And today, Wipro has, or by the time I left, Wipro has 5,000 chip designers, which is the largest ensemble of chip designers in the world, other than Intel, AMD and all those things.
Fantastic.
So that's one thing we built. The other thing I would like to state is a situation which has come in a communication industry, telecom, datacom industry. So once I went to a customer, Cisco, and said that, how are we doing? He said, you are fine, but I'm not happy with you. I said, why are you not happy? Because you want to choose the work you want to do. You want to do only development but not testing. I said, it's not true. We'll do both for you. You're an important customer for us. I came back and asked the R&D manager, why you are not doing testing for Cisco? No, sir, they want the same people who develop the product also want to test it. This is different department, that is different department. In between, there's a lot of time wasted. So I can't keep my resources idle. And also, they are very, very scarce resource globally. So I could see the reason, but also I looked at the body language and said, we are not interested in testing. So then I went to Nortel and asked them, so what do you do for testing? Yeah, it's something which you don't want to do, because we develop a product, we do the testing. That's fine. But I have to test my products with my competition product, which I don't like. So it's a specific need of a communication industry of interoperability testing.
Right.
So it is something which is big, which customers don't want to do it. We can do it. It's a huge opportunity.
It's a significant opportunity.
Correct. So I talked to many communication CTOs.
Right.
And they all told the same thing. So then I wanted to have a separate business unit called Interop Unit and asked for $2 million budget. So in our annual budget meeting, so Premji asked me, okay, you want $2 million. Okay, how much return you will give it? So I don't know. When are you going to give it? I don't know. So then how can I give money? So typical VC type questions. Then I got a idea, said that, okay, you don't invest, I will invest. So Premji said, what do you mean you invest? So you approved the budget of global R&D. So I will fund them.
Okay. From your own existing budget.
Your budget. Existing resources, assets.
Right.
So he said, okay, do it. So then what happened was I got a person who was in factory called production engineering team head, whose business is to break R&D systems. So he gets a lot of pleasure in making these systems fail. So I got that guy and saying, "We are in charge of this division. I'll give $1 million budget to you. You can do anything you want. You can use any of the R&D resources. You can go and attend conferences, courses, everything. I'll get you first customer. Second year, you have to give me $1 million profit."
Okay.
Good, okay. So I got first customer, Lucent Microsystems. And we are testing. Because we are developing also, we are testing.
Right.
So what is the price for this one? So it's 80% of the development cost. Fine. The second year, I said it should be same. So why? No, we are doing same work. Third year, I said you have to pay 20% more. I said, why? We are specialists. So we started doing interop testing for all the global top 8 datacom and telecom
Communications.
communications thing. That business today is $1 billion,
Wow.
highest margin, lowest attrition, okay, and easy to get talent.
It has come a long way. What I find fascinating is, as you explained how you went about it, the entrepreneurial way of thinking on fixing the hardware infrastructure need, software need, and training all came together by your new or creative way of thinking.
Yeah, it can be called innovation, it can be called entrepreneurship or entrepreneurship.
Yeah.
So basically, I come from a business family.
Right.
Okay, so I know the concepts of profit, loss, inventory, what to be done when I was 10 years old, 15 years old.
Right.
But I did not get into business. Didn't want to get into business, family business. But unlike many CTOs who are very much better than me or kind of situation, I had this commercial thing from beginning.
Right from the beginning.
Because of which I am able to kind of see what is going to happen. And a few other things I did in Wipro is customer is right, customer is first, which means R&D is there to serve the customer, not customer should buy what R&D makes.
Right.
Okay. All senior people in Wipro has to go and meet customers. Any customer problem has to be addressed immediately. Mm-hmm. No permission required.
Yeah.
So that culture of customer first was good. Even a new prospect comes, their first visit is to my office, CTO office. Okay. So I had to tell them, this is what I am doing, this is what I am going to do, these are all the things, take him to the lab, show the prototypes. And then next step is to go to factory, they see the things being produced.
Right.
Whereas at that time, very few companies had this kind of facilities, assets.
And another observation, as I've read about Wipro R&D evolution, is your close collaboration with academic institutions, specifically Indian Institute of Science. And that is a theme that one sees even in Silicon Valley. So can you talk through what came about it? Was it by chance or was it deliberate? What made you collaborate with them?
See, initially when Wipro was started, one of the conditions to get license is to have Indian technology or engineering. Okay. Just about the time I want to join. So Wipro decided to fund a project to University of Science, where a committee of professors were formed in CEDT, Center for Electronic and Design Technology, to advise Wipro on the architecture. And by the time I joined, it was already there. And I didn't have an office or a house. So I used to sit in University of Science in one of the professors' cabins. And many people used to think I'm a professor there. So we had a lot of discussions. So whatever we decided, I told you in this process, they were also part of that kind of situation. So in a way, Wipro was started in Institute of Science campus. So were the first these things. They used to have a program called CSIC, Center for Scientific and Industrial Collaboration.
Okay.
Like that one. So we went through that one. And subsequently, they were developing some parallel processing technologies, which we tried to use it. So that was another project. Then we had a professor from electrical engineering department who developed a software for grid optimization. So when you keep a new point in a grid, everything changes. Okay, it's not only we talk about it, the thing. So mainframes used to be used abroad. Obviously, we can't do that one. So he developed this software using the mini computer type. But user interface was bad, and it's only professor can use it, nobody can use it, all those things. So you take that code and use good user interface, graphic terminals, color terminals, and all those things. You do this, do that type scenario. So then we commercialize that software, pay royalty to Institute of Science. Then at a given time, people were expecting Mac operating systems to become a standard after Unix. Because many people ask, after Unix what? So Mac was supposed to be the answer. So we gave a project to IIT Bombay to develop Mac-like operating system there. Right. Similarly, graphics were coming in terms of usage and all those things. So we gave a project to IIT Kanpur to do that project for us. So we did have reasonable amount, I won't say large amount, but reasonable amount of interactions with the thing. But I was associated with universities very much. Right. I used to be a visitor to IIT Kanpur to select professors and their promotions for 2 years. I used to be in the selection committee of Institute of Science professors and these things. So we maintained
close connections.
Close connections.
That's something that even companies in deep tech can take away, because it can be such a good model to collaborate with academic institutions. So we talked about the initial days of Wipro and how you evolved it as a Wipro global R&D. And it's a good time to take a break and do a quick rapid fire, which will be more of fun questions that Dr. Mitta may not have answered in the past. Are you ready for it, Dr. Mitta?
Yes.
Okay, Dr. Mitta. A set of quick questions for you. Starting this one. What's one memory from your hometown? I believe you grew up in Chittoor in Andhra Pradesh. That still brings a smile to your face.
The moment you talk about Chittoor, we remember the elementary school, the day I went to school, high school, friends, picnics, all those things. But one thing I remember specifically about Chittoor is round roads. See, near Chittoor, we had a lot of hillocks with the green cover. And they were concentric motorable roads. That's why it's called round roads. The history is that the collector of Chittoor, Britisher, had a problem. His wife was suffering from TB and there was no medicine for TB at that time other than having a fresh air and other things. So he constructed it. So all of us in Chittoor, every Sunday evening, our group will go for a walk, either 2 miles, 4 miles, 6 miles, depending on that. And just outside the round roads, we had a big tank bund, green fields, then a temple. So a lot of nice memories about Chittoor.
Nice. If you are stuck in a desert island and if you are allowed one gadget to take with you, what will you take and why?
I will take satellite phone.
Why?
See, when I'm in a desert and island, so first thing is communication. So we can't get anything else. The only satellite phone has the ability to communicate. Second is, it also gives the coordinates for somebody to reach where you can ask for help.
You have been in CHIPS, so this is CHIPS specific question. If CHIPS were to give you one superpower, what would you like?
No, CHIPS give me the power. No, I want artificial intelligence with humanness.
Wow. Good answer.
Value, ethics, these things.
Tell us one quirky or fun fact about Dr. Mitta that not many people know.
I love American football.
Wow, do you watch it?
I watch it. So when I was in US as a student, I lived in an apartment next to the football ground. Lot of noise. So even if you go to library, lot of noise. I said, instead of being outside, why don't you be inside? So I went inside. And initially it looked like a brutal crime. And subsequently I started liking it. So by the time the season is over, I had 2 televisions in my house to watch 2 games simultaneously. And even when I came to India, I kept track of which side is winning, what is anything, even though we're not getting running commentaries or this one, but I keep following to the news. Okay. So obviously my favorite teams are the college team, Oklahoma State University Cowboys, and it so happens the Dallas Cowboys are also my favorite.
Okay. Very cool. So outside of technology, what's one hobby that takes a lot of your time and something you are passionate about?
I'm not a games person. I spend a lot of time. I spend, whenever I get time, reading more about technology and update myself. But one thing I do is, in the earlier days, I used to play bridge. So now I do Sudoku regularly.
Okay. So last question. A movie is getting made about your life. Who would you cast in that movie to play your role and why?
I would say Tom Hanks. The reason is I'm a introvert. Okay, so he has acted in many films where the character was important, but there's no physical exhibition of might and fight.
Right. Awesome. Great set of answers. I'm sure audience got to hear from Dr. Mitta and learn more about you that most people wouldn't know. So let me get back to where we dropped off. You talked about Wipro R&D's journey, and let me fast forward to now, right? A lot of deep tech is about building a very strong ecosystem. So for example, if you're looking at hardware or semiconductor, it'll require chip design, system design, material science, so many other skills to be available. And in India, though we have a lot of engineering skills, deep tech skills are scarce. So based on your experience of leading Wipro R&D team to great heights, what advice would you have? What practical steps could industry, academic institutions, and policy advisors take in order to build a very strong deep tech ecosystem?
See, let me start with a experience I had when I was in United States between year 98-2000. There was a study conducted by Stanford University. The question is, why is Silicon Valley great? Can you create another Silicon Valley elsewhere in the world? So it is a interdepartmental research for 2 years. They presented their findings, and in fact it was also written as a book. So I could attend that one. They said that Silicon Valley is great because of so many things coming together. And the most important thing is the ecosystem of Silicon Valley, which attracts the best talent from all over the world. It gives them the freedom, and it gives all the other things which are required, especially the risk capital and tolerance to failures. So the key word is ecosystem. So deep tech, and second question, they decided, they evaluated different places, including Los Angeles, Research Park Triangle, Haifa in Israel, Bangalore, Ukraine, and several other places, Cambridge in UK, they put a table. Every place has many things. Only Silicon Valley has the unique thing of all the things, and which is the ecosystem. And they said that Silicon Valley cannot be recreated elsewhere in the world. Okay. In fact, that answers some of the questions here. Deep tech, why Silicon Valley? Why not in Los Angeles? Same United States, same California, same set of people. So the issue is the one of building the ecosystem rather than looking only at people, only at technology, only at infrastructure, government policies. All of them has to come together. So I explained to you what are all the constraints we had at that time when we started it. And in spite of that, several IT companies, including Wipro, has come and became successful, became a global company. But today, things are different. For example, Intel wanted to produce 386 chips in India after its peak is over, so that they still demand. They said there's no way it can be done in India. They came, and then that's when it went to Israel. Okay, so to say that what is required is very obvious, saying that we need all the things of an ecosystem to be built. Fortunately, today, most of it is happening in India, not to the extent we would like to have it. So we are going to see soon some of the successes, like what happens in Silicon Valley here.
Okay. And another element of deep tech's success in any country would be IP on what you create. And there are also, I feel, Wipro Global R&D created a lot of IP that got used in some of the initiatives you drove. So any learnings from what your journey people can take away, entrepreneurs can take away on building IP that can really last the existence and growth of the company?
See, there are two types of IP. One is work of mind, patents, trademarks, and all those things, which are protected by law. More of innovation and other things. So great things need IP to protect so that you can make investment and then recoup the things. But 99% of IPs are useless or not monetizable. So that's one aspect. The second thing is in terms of in semiconductor industry, IP means reusability. You develop a hardware module or a software thing which is well defined, and they can be reused multiple times in multiple chips. Okay. For example, IEEE 1394 is a standard of IEEE, which is for the input-output. So one can take the standard and implement it so that any chip which is made where they need 1394 or a PC or this one, you can use this without developing from scratch. So that is the semiconductor IPs. These are the two things. But coming back to now, so there are different aspects of IP which are to be done. One is a strong protection of IP legally, which today we have in India. Second is the implementation. So how do you implement it? So that if there is a breach happens, it should not take tens of years. It should be done. So that means the IP system, legal system, should understand how to adjudicate in IP cases. We need lawyers. We need this one, which takes time to develop. So which is already happening, and the IP these officers which grant this one, they should have officers who knows how to evaluate and grant IP. So again, it's a question of ecosystem, of patent ecosystem coming into the country.
And you believe progress is happening on all those fronts that you talked about?
Yes, certainly it's happening.
Okay. And a follow-on question would be, looking back at your entrepreneurial journey, especially in the R&D space, what advice would you have for an entrepreneur today who is venturing into the deep tech, semiconductors, AI, robotics, those kinds of areas out of India?
Yeah, I have one advice. Typically what happens, the technical people who are into deep tech, they worry so much about technology. They look into that and keep developing it. But what is more important than technology is its usage. Okay? And applying technology is, I would say, more important than development of invention of technology. This is a lesson I got from my professor in Oklahoma State University. I went to US to do my PhD in computers. And I did not get financial aid. So another department gave me financial aid, which is systems engineering department, which I said no. There's a professor, Indian professor, who used to take interest in me. I told this what happened. He said, don't be stupid. What is more important is how to apply technology, not to learn technology or develop technology. It's required, but not that one. So that was etched in my mind, kind of situation, which I see every time. Intel spends $1 billion, makes 386 chip. But to make it a PC, you need IBM, you need Microsoft, you need digital research, you need Taiwanese companies. So many people are investing so much of money, not by Intel, but by others, which is 100 times, 1,000 times bigger than that. Am I right?
Yeah.
The difference between a successful technology company and a not so successful is, besides technology, how do I use this technology? What are the application areas? Either you do yourself or work with partners. Then only
you have to collaborate.
Technology by itself is no use.
Yeah, that's such a powerful advice. And even in my experience, it has held true for several industries which have developed products, but unless there is customers using it, the technology on its own does not make a lot of sense. Yeah, agree. So coming to today, you have been involved, you co-founded Next Wealth Entrepreneurs. The focus is social impact. Tell us a bit more about it, why you started it, where you are today. What do you think about it looking ahead?
Yeah, when I completed 60 years of age, and personally didn't have much responsibilities. So I thought it's time for me to give back something to the society. Okay. So I was fortunate to work with my co-founder Anand Talwai and S.R. Gopalan, who is no more, to arrive at what is the best way to do by our team. So we are technologists. We are in computers. So we know the market. We know all those things. So how do you use this knowledge, contacts to do social good? So several candidates came into picture. One is in education, other is in healthcare, employment, green energy, these kind of items. And if you take education and healthcare, there are huge problems, unsolved problems. It's very massive. And they are controlled by government, regulations and other things. Okay. So our ability to add value may be very infinitely small. On the other hand, if you take employment, if you provide employment, the person who gets employment gets money in hand, and that person can spend on education, spend on healthcare, and spend on other things. So we felt employment is more important than other things, not to say others are not required. So the moment you say employment, we think of using the computer industry experience of doing remotely things. So how we moved from R&D to global R&D. Okay. So we are working here. If work can come from United States to Bangalore, 5,000 miles away, why can't work go from Bangalore to Salem, which is 200 miles away?
Right.
So that is the for which, provided you have internet.
Right.
So employment became the primary criteria of creating social impact. Second is to whom? It could be graduates, it could be PhDs, it could be engineers, it could be uneducated people, whatever it is. But the maximum impact we thought we can create when we can employ graduates kind of situation, because these people spent 4 years or 3 years of time, money, the college has spent, the government has spent money and all these things. After graduation, if they don't have a job, it's useless. In fact, he will be in a worse position than uneducated. So, next thing is where. So, it could be in a city, it could be in a village, it could be a town and all those things. Because of our IT background and internet needs and other things, we said it should be small towns, not villages, but not cities, because city already has so many other opportunities. And making people move from small town to cities is creating more problems. So we said cities. Within that, 60% of the graduates coming out are women. And the women, after education and all those things, they are not allowed to go out of their small town to take up opportunities, even if they get it. So women became important. Plus the fact that women's money in women's hand is spent much more effectively than men. So these are the reasons based on which the purpose was defined as providing gainful employment to graduates in small towns focusing on women. So that was the beginning, and that's what we do now.
Wonderful.
Today we have 11 centers, 5,000 people are employed. We are a for-profit company, though it's a social venture. And we are profitable from day one. For us, profit is not the motive. So for us, employment is the motive. To get employment, you need to get revenue. To get revenues, you get profits. From revenues, you get profits. Whereas a normal company, you get profits, or you want to get profits, for which you need revenues, for which you have to get people. So,
very, very interesting. And you are an absolute inspiration, Dr. Mitta. You have done a variety of different things in your life and continuing to do it. I'm sure the next generation listening in or watching this episode would take a lot away from this journey of yours, which has been a pleasure to talk to you. And we are coming close to the end of the show, Dr. Mitta. So it's been such an inspiring episode for me, and I'm sure for the audience as well. So there is one question that I plan to ask all the guests. It is this one, that India's ambition in semiconductors and deep tech is not only about domestic growth, it's about our place in global technology. And if you were to fast forward 10, 15 years, what's the most profound way you hope India's success in building this ecosystem will have in the global world order? Whether it's in terms of impact it creates or whether it's in terms of human capability improvement.
So from a technologist point of view, I see the line between hardware and software has blurred. Okay. And it is blurred between a chip and a system. Okay. And with artificial intelligence and generative AI coming into picture, so these chips become a delivery mechanism for certain specific tasks or these things. Today we are sitting here and trying to build a ecosystem to make semiconductors. It's important. But can you make semiconductors which are different from the way others do it? Okay. Where the solutions are not specific to rich people, but it can be used for so many other people. Because today technology is not inclusive, not kind of everybody who needs it are not getting it. So to make this technology available to everybody in a way they can use it, they can afford it, it has an impact, and at the same time, it doesn't have a negative impact. So the opportunity is unlimited. Okay. Where India comes into picture is we have this ability to find out what those problems are, because we have 1.5 billion people. We know we have more problems than we can solve, and applying to them, and then propagating to the globe will be a great opportunity. As again C.K. Prahalad told, you don't have to search for problems in India. We have a million problems. You can choose any problem and solve it.
Thank you, Dr. Mitta. Thank you all for listening in. Please follow us on Chai and Chips, the channels that you listen to this podcast. We look forward to bringing back several such inspiring episodes in future. Thank you.
Thank you, Prakash.
Thank you.